everyone. This is Tabitha Bennett, executive producer of AWS OnAir. I am here with my co-host, James.
I am still here. Haven't moved. Glad to be here again.
That is true. We are still here. And we have a lovely guest. Why don't you introduce yourself and where are you from?
Hey, welcome. Thank you. Thank you for the warm welcome. Hi, I'm Pavni. I'm the principal product manager for OpenSearch Serverless. And this reInvent has been particularly exciting for our OpenSearch service team. And I'm here to be talking to you about Vector Engine for OpenSearch Serverless.
Now, she actually said she wanted to hop right into the demo because it's that amazing. And I know with those who are open search serverless people, you know, they love this stuff. So let's just show what we have here, and you could just kind of walk us through what's going on it.
Yeah, I mean, if we talk about what Vector Engine for OpenSearch Serverless enables is it enables a RAG framework. The theme this year has been generative AI, right? And the two ways.
Jennifer AI. We made a drinking game out of
it. Yes. I had a little too much on Jennifer AI.
Yeah, and so we have two ways you can build, conversational applications. One is you could fine-tune the model, and the second one is the RAG framework. And in RAG framework, what happens is you're converting all the content into vector embeddings. And what vector embeddings does is it basically helps you pull out the most similar vectors, which is building the context. So, for example, when we are, as humans, we understand the context. But for machines to understand context, we convert them into vectors. And then the vector engine basically performs similarity search on those vectors.
Okay.
And it runs an algorithm. It's a k nearest neighbor or approximate nearest neighbor algorithm to find the closest match. Good example is that, when in this particular demo, what we've done is we loaded up all the OpenSearch manuals, blogs into this, RAG framework. And earlier, if you have to find out, say, how do I configure VPC on OpenSearch Serverless, you have to make sure you have the exact match. But here, you can just say, can you help me configure VPC on So what it's doing is it's trying to find the keywords from this, convert the query into, and basically the query is converted using Titan embeddings. And then it's basically sending it to Vector Engine, which is storing, it can store billions of vectors.
Yeah.
Wow.
Running similarity search, you're getting the content back. That content is now basically augmented to the prompt, and then the prompt is what is generating the text for you. So you can see that the response over here is much more personalized. And it's like, look at this. Let me know if any of the process needs more explanation. So this is what the industry is moving towards with generative AI applications. They're trying to make it much more interactive, and it understands the context. And for vector embeddings, I think one of the key things is basically you need a really scalable, simple vector database that can take these and basically convert, and handle the vector embeddings at scale. And that's what Vector Engine for you does.
Wow.
So it remembers the context of what we just asked it, like you said right there at the bottom. Do we need more explanation? And it won't just continue with like a new search. It'll remember.
Yeah, exactly. It remembers. So that's the other benefit is the long-term memory, right?
Which I do not have. No long-term memory here.
Yeah.
What?
Yeah.
Yeah. So and also we wanted to talk about two features that we've added. So we did preview this at the New York Summit.
Nice.
And for the GA, I think. First of all, thanks to all our customers, we've gotten great response. But for GA, I think a lot of customers have said that they're still in the experimentation stage. So they really don't want to be using up, the high availability feature that we have.
Right.
So now we have a dev test mode, which reduces the cost by half.
And I like that. I like it when things are reduced and prices are cheaper. I mean, that's customer at its finest.
Exactly. And if you have very few embeddings, right, or because you're in the experimentation stage, we start the billing with even half OCU. OCU is our capacity unit.
Okay.
So that reduces it further. So
Nice.
yeah, so I think that is something that we're really excited, because cost optimization has been, again, one of the themes this year.
That is the thing. Besides Jennifer AI, it's making things as cost effective as possible for the customers. Exactly.
And especially when we're releasing new things and people want to see how they work, see what the use cases are. People don't want to dive into something that they don't know.
Pay full price for something that might not be
I don't
for
even
them.
know if I need this, but if I do, I want to be able to get there without too much investment.
Exactly.
Absolutely. And in case of generative AI, as you must have heard, since you've had so many of these,
I'm sure we have.
people want to play with different models, right?
Yes.
So and that's exactly the point over here. When they want to play with different models, different chunking strategies, you want to be able to reduce the cost, and that's one of the features. The second big one is billion scale. At preview, we had limited scale, but we have also customers who want to first experiment, then really scale to their billion vectors or really large numbers, millions of vectors.
That's a billion vectors. Not millions, but billions, which is a lot.
Yeah. So they can basically use the same, OpenSearch serverless, all the features, which is reliability, durability, and easily transition from experimentation to production on the same platform.
Wow. I think that's pretty awesome.
That is awesome. I love it. I love anything that makes it easier for me because, I'm not the strongest, I'm not the smartest. So anything that makes it easier for me to be able to work with those kind of things, definitely.
Cheaper and easier is always, I shouldn't say cheaper, I should say cost effective, I'm sorry. And easier is always a good thing.
Yeah.
Awesome. Well, I guess the next question is, how do people find out more about this?
Great. I mean, we have a lot of documentation framework, and also they can go to our AWS documentation to find more on vector engine for OpenSearch serverless.
Nice, nice.
We have a couple blogs, and what's really great is that customers have already started playing with the RAG framework, and there are a lot of examples on GitHub as well.
Wait a minute. It can be integrated with GitHub.
No, it's on GitHub.
It's on GitHub.
Okay.
Yeah.
Didn't I say no long-term memory?
Right.
There goes the short-term memory too. I'm screwed. That's just great.
And just for people that are absolutely not me, what is a RAG framework?
Yes.
It's
absolutely not me. I totally know what that is.
It's the it's basically retrieval augmentation framework.
Got it. Okay.
Retrieval augmentation generation is what it's called. So typically what happens is, when you're building generative AI applications, you can either fine-tune the model. That's great. That works well for static content. But if you have fairly large content and it's there's a lot of documentation and you want frequent updates, what people do is they go towards this particular framework where you can basically create embeddings and keep updating the embeddings so that your answers are more contextually relevant.
Oh, okay. Cool.
Nice. Very nice.
There's
Go ahead.
Yeah. There's also the hybrid search aspect over here, right? So the other advantage of using vector search, vector engine, is the fact that now you can combine lexical search with vector embeddings. So a good example is if there is particular data type that's constantly changing, say it's the the movie score over here, or if it is on a retail website, the prices that are changing. Or if you want to basically pull by certain brands, what you could do is you can basically have them as, you don't have to vectorize them, you can just have them as text or keywords while you vectorize rest of the data, right? So with that, what happens is you can filter by that metadata and you basically get more contextually relevant answers.
I just thought of that actually. So when we're talking about vectorizing and being things that are more related and closer together, when we want to have exclusions, like even though the model might think these things are related, but it's not what we're looking for, we're able to exclude things as well.
Yeah,
Is that what you're saying?
yeah.
Okay.
So basically in the response, you can add more keywords and basically, and then run vector search on top of it. So you're basically, what you're doing is you're getting a more contextually relevant. You're trying to basically look at only the precise answers for that particular question.
Got it. Awesome.
That's pretty darn handy. I mean, that way you're not getting the stuff that you don't really want to see and know about and waste time trying to sift through everything.
Exactly.
It's easier to get right to the point and say, okay, it's A, B, C. All right, this is what I want.
Yeah. Normally,
That's
people,
awesome.
if they have to do this, they'll have to have 2 different application pipelines, do different vector stores. But with Vector Engine, you can get everything in the same, store.
And I see right here this little scale about rating. We can adjust that so that we can add more broadness. Or
Exactly.
Okay.
Yeah, absolutely.
Nice. All right. Well, is there anything else you have to say
No.
to our lovely?
Yeah. First
Lovely
of all,
audience.
thank you. I think we've got some great response, since the preview, and we definitely heard their message loud and clear that they wanted, dev test mode. So we brought that in, and the billion vector scale. So we can't wait for them to get started.
I love that. I mean, ultimately, the customer asked for it.
And
You gave it to them.
Exactly.
We heard you. We will
Yeah.
continue hearing you. All right, everyone. Thanks so much for joining us. We are going to go to a quick break, and then we'll have another session up here ready for you. Thanks a lot.